Welcome back to another lesson in MCV4U. Today we'll be looking at the dot product of geometric vectors. Recall that geometrics do not have a coordinate system associated with them. So when we look at the dot product definition, a dot product is of two geometric vectors, vector A and vector B, with an angle theta between them when positioned tail to tail, is a scalar value. The scalar value, again here, defined by the vector AC times the vector AB is equal to the magnitude of vector AC times the magnitude of vector AB cos theta, where theta is between 0 and 180 degrees. So here, if we look at, again, the diagram that's provided for us on the right, again, here we see that we have vector A, we have vector B, we have our theta that's in between. And here we can just draw a line that, again, looks at our resultant vector here. Again, the dot product applies the directional growth of one vector to the other. The result is, again, how much stronger we've made the original vector. So again, how much stronger we've made the original vector. Again, positive, negative, or 0. And the result of the dot product is always a scalar value. The dot product is also known as the scalar product. Again, the dot product can be positive, negative, or 0, again, depending on the angle between the two vectors. So for the vectors vector A and vector B, and vector A times vector B is equal to the magnitude of vector A times the magnitude of vector B cos theta, again, where theta is between 0 and 180 degrees. So again, if we draw coordinate plane here on the right, okay, so here, if we see again where the values of cosine are positive and negative, so again, using our cast rule, again, cosine is positive in quadrant 4, quadrant 1, quadrant 2, and quadrant 2 is negative, and cosine is negative in quadrant number 3 as well. Again, we're only focusing from 0 to 180, so again, we don't have to worry about, again, the values in quadrant 3 or quadrant number 4. Over here, if we look at, again, 90 degrees, and we'll just have the point at 0 and 1. Again, we see we have cos theta is equal to cos 90 degrees, again, is equal to x over r. Again, in this situation, x is 0 and our r value is 1, so that's equal to 0. Okay, so here if we look at the three cases, again, if the theta is between 0 and 90 degrees, again, then the vector A times B is greater than 0. So here, we'll draw this on the right. So we'll look at case 1. Again, if it's between 0 and 90 degrees, okay, theta is less than 90 degrees. Again, that means it will lie in quadrant number 1. And so here, cos theta will therefore be greater than 0. This is positive. So vector A times vector B here will be greater than 0. So here, if we look at, again, our magnitude of vector A times our magnitude of vector B cos theta, so we know here that all three values will be positive. If we look at our second case here, again, if it's between 90 and 180, then again, magnitude A times magnitude B will be less than 0. So here, case number 2, again, theta here now is between 90 degrees and 180. And so that means that will lie in quadrant number 2. And therefore, since it lies in quadrant number 2, that's when cos theta is less than 0 or negative. And we see here that vector A times vector B will also be less than 0. And so here, when we look at, again, our magnitudes, again, our vector A times vector B, those will be positive. But here, again, because cos theta is in quadrant 2, that will be negative. Okay, and then case number 3 is if theta is exactly at 90 degrees. So theta is exactly 90 degrees. Again, here now cos theta will be equal to 0 based on what we looked at in our diagram we drew at the top. And so here, vector A times vector B will also be equal to 0. And so here we will have positive, positive, and then cos theta being 0. Okay, so based on that, let's look at a couple of examples. It says if vector u is equal to 4 and vector v is equal to 6, and the angle between them is 120 degrees, you can find vector u times vector v. So here we have vector u times vector v is equal to the magnitude of vector u times the magnitude of vector v cos theta. In this situation, cos is 120 degrees. Here we know that u is 4, v is 6. And if we look at cos 120 brings us to quadrant number 2. In quadrant number 2, we look at here, cos 120 will give us negative 1 over 2. And so here we get 4 times 6, which is 24, times negative 1 over 2. And so here we get vector u times vector v will be equal to negative 12. And so here, again, that stays consistent with case number 2 that we saw. Okay, so here, example number 2 says find the angle between two unit vectors having the dot product equal to 1 over square root 2. So again, when we see that it's a unit vector, you can see that the unit vector A is equal to 1, and we can put that the unit vector B is also equal to 1. So here, vector A times vector B is equal to the magnitude of A times the magnitude of B cos theta. Here we're looking at the unit vector A times the unit vector B is equal to the magnitude of unit vector A and the unit vector B cos theta. We know that, again, the dot product is equal to 1 over square root 2. And here both the magnitudes are 1 cos theta. And so here we have cos theta is equal to 1 over square root 2. Since here cos theta gives us a positive value, we know that here it'll be in quadrant number 1, and therefore cos theta is equal to 1 over 2 when theta is equal to 45 degrees. Okay, if you look at some other properties of dot product, okay, so here if vector A is perpendicular to vector B, then here we see that vector A times vector B will be equal to 0. If the dot product of vector A times vector B is equal to 0, then we see that again, vector A will be perpendicular to vector B. If vector A, again, they both go in the same direction here. So here we can draw, and we have vector A, and here vector B. So here they're in the same direction. And so again, we see here that the theta would be equal to 0 degrees. So since theta is equal to 0 degrees, cos theta, or sorry, cos theta or cos 0 is equal to 1. And here the dot product of vector A times vector B is equal to the magnitude of A times the magnitude of B. Because again, cos theta in this situation, cos 0 will be equal to 1. Here, if vector A and vector B are moving in opposite directions, so let's say vector B moves to the left, vector A moves to the right. You see that here, the angle that gets created is 180 degrees. Here we see that cos 180 degrees is equal to -1. And so here, then the dot product of vector A times vector B will be equal to negative the magnitude of vector A times the magnitude of vector B. Here, if we have two of the same vector, so vector A times vector A is equal to the magnitude of A squared. Here we have vector A and vector A. And here the angle is 0 degrees. And so therefore, that's why when we have the vector A times vector A, it's equal to the magnitude of vector A times the magnitude of vector A times 1, which is equal to the magnitude of vector A squared. Again, the commutative property states again that if that vector A times vector B is also equal to the vector B times vector A. So again, you can reverse the order. Here again, distributive property. So vector A times bracket vector B plus vector C. Again, we're distributing the vector A into both the vector B and the vector C inside the bracket. here, if we have a, a scalar quantity of k multiplied by vector a times vector b, again, we can also write it as k, the scalar, times vector a times vector b, or we can also write it as the vector a times the scalar times vector b. And finally, the last property here is vector a times 0 is equal to 0 here. Okay, so these next couple of examples, again, we're going to use these properties, again, to prove each relation. So here we have a plus b, vector a plus b times vector a plus b is equal to magnitude a squared plus the magnitude b squared plus 2ab. Okay, so here, let's look at our left side. So here we can first expand. So again, we will distribute, and here we'll get vector a times vector a plus vector a times vector b plus vector b times vector a plus vector b times vector b. Okay, so here that will give us vector a squared plus vector a times vector b. And here, vector b times vector a, we can rewrite as, again, vector a times vector b, and then plus, and then plus b squared. And so here you get vector a squared plus the vector b squared plus 2 vector a times vector b. And so here we see that our left side is equal to our right side. Okay, so b here, then we have vector a plus vector b times vector a minus b. So again, we are going to distribute again. So here again, our left side, we want to make it equal to vector a squared minus vector b squared. So here we get vector a times vector a minus vector a times vector b plus vector b times vector a minus vector b times vector b. So here we see that the negative vector a times vector b and the positive vector b times vector a can cancel out. And so here we get vector a squared minus vector b squared. So here we see again that our left side is equal to our right side. And lastly here, again, it says if the vectors 2a plus b and vector a over 2 minus b are perpendicular to each other, and 2 times vector b is equal to 3 times vector a, find the angle between vector a and vector b. Okay, so the first thing we're going to do here is we're going to let m or vector M is equal to 2 times vector A plus vector B. And we're going to let N equal to vector A over 2 minus vector B. Okay, here we know a few things. We know that 2 times vector B is equal to 3 times vector A. So here we can write that vector A is equal to 2 over 3 vector B. Here we know that they are perpendicular, so here we can write that vector M and vector N are perpendicular. And so that means here theta is equal to 90 degrees. So we know that the dot product, M times N, will be equal to 0. So based on that, we can sub back our M and N. So for M, we have vector 2 times vector A plus vector B times N, which is 1 over 2 vector A minus vector B is equal to 0. And here we're going to distribute. Again, so when we distribute, we'll get vector A times vector A minus 2 times vector A times vector B plus 1/2 vector B times vector A minus vector B times vector B, and that's all equal to 0. So here, again, we're going to put together negative 2 vector A times vector B plus 1/2 vector B times vector A. And so here we have vector A squared minus 3 over 2 vector A times vector B minus vector B squared. So here we have vector A squared minus 3 over 2, and then the dot product of A times B, so that's the magnitude of A times the magnitude of B, and the cos of the angle minus vector B squared is equal to 0. And so here we again know that, here again we know that we can sub back in now we can sub back here. We have our vector A is equal to 2 over 3 vector B. So let's sub that in. So here we have 2 over 3 vector B squared minus 3 over 2 times 2 over 3 vector B. So here the 3 over 2 and 2 over 3 can cancel out. Vector B times vector B cos beta minus B squared is equal to 0. So here at 4 over 9 vector B squared minus vector b squared cos beta minus vector b squared is equal to 0. And here, 4/9 vector b squared minus b squared will give us negative 5/9 vector b squared is equal to vector b squared cos beta. Divide both sides by vector b squared. And here we're left with negative 5/9 is equal to cos beta, and therefore beta will be equal to 124.